Welcome to Study Loop.
Okay, so if we are to use a galvanometer like an ammeter, then we have to use a shunt resistance in parallel with the galvanometer. So let's write that galvanometer and shunt resistance in parallel. So you can find this diagram in 1931 uh, as well. So what we need to do here is the internal resistance is given, which is 32 ohms. So R, small r, is 32, and the shunt resistance is 55 microamps. No, sorry, the shunt resistance is something that we need to find out because we are given the current 25 amps, and from there we'll try to find out this guy. Now you see we are using ammeter as a galvanometer. Now the total current I is been divided to two parts. One is the current that is passing through the galvanometer, and the other one that's passing through the resistance. So we know that since they are in parallel connection, the voltage difference on these 2 points will be equal for both of them. So that means we can write V shunt is equal to Vg. So that's the voltage difference in voltage difference across the galvanometer, and that's the voltage difference across the resistor. Now using Ohm's law, we can write I minus Ig. So as we mentioned, I is the total current. So I minus Ig is the current that's passing through the resistor. That times R shunt, or in our case RSH, is equal to Ig times little r. And from there, if we try to solve for RSH, we get Ig times little r divided by I minus Ig. Right. So our Ig is given, which is 55 microamps. So we convert that to amps. Then our little r is 32 ohms, and our total current I is 25 amps. Right, so if we plug in all the numbers here, we get our R as 7.5, sorry, 7 times 10 to the power minus 5 ohms. So that's the um, resistance that we need to make the galvanometer an ammeter. Now for voltmeter, we see the total voltage that we need is 250 volts. So that's the diagram, and if we look at figure 19.32, we'll see a similar diagram like this. Now in this case, the voltage, um, so yeah, in this case you see that these two guys are in series connection. So that means the total resistance times the current passing through the circuit should be equal to our full scale voltage. So V full scale should be equal to Ig, that's the current that's passing through the circuit. Since it's a series connection, so the current is all the way same, and since they are in series, so we can write R SER plus little r. So from there we'll try to find the external resistance that we need to put. So RSER is equal to V full scale over Ig minus R, right? So now we know that V full scale is equal to 250, is equal to 250 volts. Yeah, 250 volts. And then again, Ig is given, which is 55 milliamps. So we convert that to, 55 microamps. So we convert that to amps. And then R is 32 ohms. So yeah, if we put all the numbers over here, and then we get the value as 4.5 times 10 to the power 6 ohms. So as we see that to make a voltmeter out of a galvanometer, we need really high resistor, or we really need high resistance, and that should be connected in series. And for ammeter, we really need very low resistance, and that should be connected in parallel. Thank you.